Okay, I know it's been a minute, but here's a video for repairing my personal FTL meter made by LDG. This hooks up to my Yaesu FT-897 ham radio transceiver. I've had this for, I would say over 10 years, maybe going on 11 or so. And it's a nice external meter for the Yaesu radio because the radio itself has a very, very small LCD, and always liked having an analog meter on my ham radio. So I purchased this several years back, and it worked perfectly. I mean, there's really nothing wrong with its function. Uh, the problem I'm having with it is the backlight. So first of all, let's take a look at the LEDs in the back. There are 3 rows of blue and white LEDs, and they shine at the back of the white movement here, and they reflect light inside this box. There's a cover that goes over this, obviously, and it illuminates the back here, and it gives it a bluish, whitish look to it, more blue than white, but um, so these LEDs are all fed through a resistor. I believe they're a 470 ohm resistor. And then they go to a LM7805 regulator right here. So out of this regulator, um, it powers the LEDs. But the problem is this regulator is not running at 5 volts. It actually has a variable between 5 and rail, and I'll show you that on the schematic in a moment here. But so you are able to, with an adjustment pot, which is on the back of the unit here, adjust the brightness. Now what this does is adjust the voltage regulator that is on this circuit here to between 5 and your rail voltage. So whatever you're powering um, this meter up with is what this regulator is going to see on the input and on the output if you have this pot set all the way up. Now there is a dropping diode. I believe that's it right there. It does bring this down about, a half a volt, 0.6, whatever that junction is on this particular diode. I think it's a 1N4004. So we're going to say a half a volt or so. So if you're putting about 12 volts into this, you're going to see 11.5 at the input of this regulator. So it does drop down. There's an RF bead in here that chokes off some of the possible feedback coming in. But that doesn't really affect the voltage of this. So here's the issue. These diodes with a configuration with these resistors at 12 volts is fine, I believe. I think I've done the math at I will have to do it again, but I believe they were closer to the rated milliamps that these LEDs would like to see. Now, when you run your ham equipment at, let's say, 13.8 versus the 12 volts that is typical, you're going to chance running this a little hot if you have the brightness turned up all the way, which will, over time, dim these LEDs to a point where the backlight isn't very good. And that's where I'm at right now with this meter. I don't think there's anything wrong with this regulator or anything else. I believe the LEDs have just faded off over time with just a little bit too much extra current feeding them. I'm going to shut the lights off here and show you what it looks like without with just what you can see. It's not very impressive in this state, and I mean, you could say that the cover's losing some of the light, but it's not really that much of a difference. Yeah, it's I don't know if it's really relaying the amount of how dim it is in real life compared to what you're seeing here, but it is almost unreadable at night from about 3 feet away, which is about how far I sit from it. And I would like to see a little bit more heat on these LEDs. Um, so the solution here is not to, let me turn this light back on. The solution here is not to try and adjust these resistors to compensate for the LEDs, dimming over time due to possible overcurrent. That would just be compounding the issue here. So I would not suggest doing that. I would suggest just replacing the LEDs with new ones. And I have several here, and I believe they're 0805 size, blue and white. I've got them off Amazon really cheap for I think about $6 or so, for 20 of several different colors. So I'm not too concerned if this doesn't work out or not, but I just wanted to try and see how this works out. So you want to change the LED, not change the resistor and try and make them brighter. That's not the solution, because eventually you're going to overcurrent them even more, and then eventually they're just going to burn out. All right, so I am sitting with the schematic now, and this is the LM7805 regulator. Traditionally, on this pin here, you should have 5 volts out, but this is hooked up in a fashion that is not the case. It can be, but depending on this potentiometer right here. This, according to the data sheet, is called a positive regulator in negative configuration. And what happens is as this potentiometer pulls away from ground, when it's at ground, you will have 5 volts out here. But as it pulls away from ground, this output will rise to the input voltage, or pretty close to it. There is a diode in the circuit, and when you feed your 12 volts into this, you're going to drop about a half a volt through that diode. So let's say you put 12 volts into this, you're going to get about 11.5 into this regulator. So roughly, if this is at a higher setting here, you could potentially have almost 11.5 volts out on your LED circuit here, which is fine. That's the way it's designed. But as long as your resistors and your LEDs are and your voltage in are all happy working together. And that is the reason why I don't like this circuit, is because a lot of people will run their power supplies, like myself, at about 13.8 volts. So you can have a variation of people that run it from 12 to 13.8 volts and anywhere in between. And unless you adjust this potentiometer to compensate for that, if you have this on 13.8 volt supply and you have this cranked all the way up, these LEDs are going to get a lot of extra current that they're probably not supposed to have. Right here we have a little inductor here, and this is kind of pads the LEDs from when you turn on and off the LEDs, pads the circuit a little bit. But let's take a look at these resistors, because this is the interesting part. We have the blue LEDs are running through a 470 ohm resistor, and the white LEDs are running through a 220 ohm resistors. So that tells me that the original LEDs have two different current values that they like to operate at. The ones that I have purchased actually they both have the same current consumption, which is 20 milliamps. So me saying earlier I didn't want to change the resistors, I'm probably going to have to, but for a different reason other than the one I stated before. Because if I go and put my 20 milliamp LEDs in with these 220s, they're going to go quick. The 470s, they're probably going to be okay. I'm going to actually change them all out to 470, and I can adjust the circuit here to my satisfactory calculation voltage output. So until I'm happy with the current consumption of all these LEDs, I'm going to start with a one blue and one white in one quadrant of the meter to see how it looks, because I'm not sure if they were actually trying to either compensate for the current draw, or they actually trying to balance the light output. So I think I'm just going to try one and one first and see how that goes. Before I start unsoldering these LEDs, I actually want to come up with a general calculation of current that I'm going to see here. So at 12 volts through the 470 ohm resistor, I should have 25 milliamps, and that's 5 milliamps too high. So I've done the calculation. I'm going to need to be around 9 volts along with these 470 ohm resistors in the LED to get around 20 milliamps. Okay, so I have the meter now hooked up to a power supply. You can see up here in the top right corner, we're set to about 13.8 volts. And right now we're consuming a current of about 82 milliamps. And that is because I have the variable brightness variable resistor turned all the way down. And that is why we are seeing only 5 volts. That is the output. I have one of these probes on the pin to the output of the LM 7805. So that is the result when the pot is all the way down, so it's grounded. Let's turn it up a little bit here. Let's actually turn it all the way up. And we can see the voltage start to rise. But see where it tops out. 9 volts there. All right, so it seems to top out around 11 volts. Like I said, it drops across that diode and probably has some internal dropping on that regulator. I tried to look at the data sheet to see what kind of drop would be in this configuration mode, but there's really not that much information in the data sheet about running this regulator in that configuration. So, so I'm not sure what the deal is with that, but let's move on. It's not a big showstopper here. So I'm going to turn this back down to 5 volts. Actually, no, I want to set this to about 9 volts. I think that is where I said that I want to have it roughly right about there. So when I change out these resistors here, well, actually one's a 470 and one's a 270. So I'm going to change to 270 and replace both lamps. And I should be running at 9 volts with those resistors. I should be running the LEDs at 20 milliamps, which is proper. And I have to just put a piece of tape over this not to adjust that anymore. That's as bright as it's going to get. Okay, so this is the board under the microscope, and we have the resistor and the LED right here. I'm going to try and do this the quick and dirty way first, because I don't want to spend a whole lot of time cleaning the board and everything, and I'm just going to get these stuff off and plant the new ones on. I just want to make sure everything's going to work before I go and go crazy on everything else. Yeah, those LEDs, they had some discoloration on them. Look at that. Yeah, these are done, huh? Okay. So now I'm going to put the resistor in its place. Okay, so now I've hooked the power supply back up to the 2 pins here. I basically have just soldered on a couple of extra leads on the solder points so I can get these clips on here. But this is the one we just replaced along with the resistor. So the resistor now, R8 now matches R2. And if I find that this works, I can change out just this LED and do the rest of the other 5. And hopefully this will be done. So let's see what difference that made just by changing the LED and resistor and running this properly. I don't have a multimeter hooked up to this, just power. So we're just going to be seeing, we already set this to 9 volts. So we already know that we should be pretty close on. So let's power this up, see what we have. Oh, well, I guess there's your answer. So absolutely, that made the difference, all the difference in the world. So these LEDs are definitely starting to die. This is the white one. I'm going to put the blue one in. And yeah, I actually may have to turn back that regulator if I find that 9 volts, its max setting, might be too bright. So that'd be awesome because then I can run these cooler and this will practically last forever. Well, I shouldn't say forever, but a lot longer. All right, so now I'm going to do it the way I would usually do this because I don't like heating the LEDs onto the board. I know you can, but I think it just adds a little too much heat to them. So I'm going to do it my normal way, which is I'm going to flow one pad and have one pad empty. So I've already got one started right here, and I have these two other ones cleaned up here. I will just get this on here. That just makes things a little bit easier. And you don't risk cooking the LEDs. Kind of at an odd angle on the side, but there we go. So I'm just finishing up these last few LEDs here. Gonna have to clean this board after. But let's see if we can get these last few in here. Okay, let's throw some power on here and see how it looks in the dark. And let's see. That's going to be positive. That's going to be negative. Oh, let's turn that off. All right, so let's turn it on here again. Wow. Okay, let's let's turn the lights out in the shop here and let's see how it looks. Yeah, let's get it even darker in here. That is much brighter here. That is way more visible than it used to be. That is great. The color is accurate. It's just like it was before. just to make sure we didn't move anything. I'm going to see what kind of voltage we got coming out of this regulator. I'm hoping it's right on 9 volts because that's where I want it, and I like the brightness. Yep. Okay. That's perfect. Maybe eventually I will come up with a redesign of this circuit, because as of right now, you could tweak that part higher and potentially run into the same situation this thing ended up in the first place. So right now, if this ends up being too bright, I'll have to tone it back, and that's it. Nail it down, put a piece of tape over that hole, and call it a day. But I'm gonna try it at this brightness. If I like it, I'll just go with it. So I'm in the shack listening to a conversation on 2 meters, and I'm just looking at this meter, and it is just awesome. It looks exactly like it did when I first got it. I'm very pleased on how it came out. And if any of you guys are looking to restore your FTL meter, I'll leave a link in the description of the LEDs I used. As you saw, you might have to tweak a couple of the resistor values on the white LEDs, because they are 2 separate values from the blues. So you will have to come up with your own formula on how you like it and what color balance you would like. But I like it the way it came out, just using all 470 ohm resistors. So that's going to do it for this one, guys. And I hope you have a great night, and we'll see you in the next one.